So let's start. So today basically we're going to understand the internals of Kubernetes. We'll understand how it basically works. I was going through this one of the book which is Kubernetes in Action, and then it gave me good insights. So just I wanted to share with you guys. Uh, yeah. So let's start. So basically, whenever it comes to our mind about Kubernetes, we just think that yeah, we deploy the Helm chart, Kubernetes takes care of it, everything, it scales, we provide all the replicas that needs to be there, and just Kubernetes takes care of it, everything. Uh, all the time, if the pod goes down, it starts, restarts everything, and it takes care of it. But what happens internally, we don't know, right? At least I didn't know. So uh, yeah, so there are few components that makes the Kubernetes what it is. The one thing is let me, yeah, so the first point is the API server itself. Okay. Second one is the etcd, and the third one is controller manager, and the fourth one is scheduler. And we also have few things which are remain on the worker node, so let me also write it down. We'll understand all these things. How does it work basically? The kubelets are there, and the kube proxy. Okay, so let's go one by one what it is. So the API server, as the name suggests, it is basically the server itself, which takes all the requests. Okay, so let's suppose if you have a client, which in our case it can be anything, but usually the one we interact with the most is like the kubectl CLI. So this is nothing but is one of the client which interacts with the API server, and API server is the one which handles all the requests coming from the client. So and yeah, this is the main main component of the Kubernetes, which is the front facing of all the clients. And then etcd is nothing but a key value data store, and it is distributed in nature. So yeah, it makes sense for Kubernetes, because we will need to, when we scale into multi-cluster or for high availability, we'll need something which stores this data in a distributed manner. And yeah, so another thing is controller manager. So controller manager is the one which actually handles the request. API server doesn't handle the request, it just delegates it to control manager, you can say. But it happens the other way. We'll talk more in detail about this. And then there is this scheduler which actually schedules the creation creation and deletion of the pod. And then this is the worker nodes. So worker nodes are nothing but you can say this, the whole Kubernetes are divided into two things. The one is the control plane, which is the one that above four components are part of. Then there's this other worker nodes which are part of this data plane, right? So it handles everything, like actually doing the job on the worker node. Okay, so that's what it is. So here the client also can be something like a UI as well, something like OpenShift is very famous to manage the Kubernetes cluster. So yeah, these things like interacts with the API server. So for example, let's suppose if you want to create a pod, okay, and let's suppose if you want to uh, increase the replica of any service, any instances, right? So those things, the everything in the Kubernetes that is happening, all the states that is are going on, everything is stored in etcd. Okay. So Kubernetes can refer that, fetch all the status from the etcd, and it's the API server which only interacts with etcd. No one else, no other components in the Kubernetes interacts with etcd. Everyone else just watch the event, which are published by the etcd, and that's it, and all work on it. If they require any changes or anything, they just interact with etcd API, API servers, not directly work with etcd. So what happens is, like, let's, in the diagram above we can also see, like, API server has few requests that will be coming from the, let's suppose this is the client. It will send this request directly to API server, right? And this API server will, let's suppose, it has, it came the request to increase the update the deployment, right? So everything is an object in Kubernetes. So deployment, you must have seen some YAML file are there which has all these objects, the replica sets, pods, and deployment and services. Everything is just called object in this Kubernetes context, and it is stored in etcd. Okay. So let me also write over here, etcd is the one where it stores. So this API server stores in the etcd, and whenever any state changes happens, it publishes the event, uh, to all the subscribers. So these components, so as you can see, deployment controller, API set controller, and scheduler also, they subscribe, they register themselves as a notification uh, listener to API server. So whenever each, whatever they are responsible for, if that event comes, that component handles that particular event. So let's suppose this deployment, we client updated the deployment, then the deployment event was triggered, right? And first of all, it goes through API server, goes through several uh, pre-processing before even saving to etcd. One is like authentication, second it goes through authorization, and then it does handle the uh, verification, validation, you can say, and then only it stores in etcd. So only after that it happens, then it will create the event, and then it will send it to the notification listener, which in this case is deployment controller. And this one will, what it will do is like, it will again hit the API server to create a replica sets. Okay. And a replica set is created, it again, it's follows the same process. It goes through, but in this case it can skip the authorization and authentication. It goes through validation, and then it will be saved to etcd, and then it produce the replica set control event for the replica set controller. This replica set controller in turn will create a pod. Okay. So once this pod is created, this details is saved into etcd. Okay. And then an event is triggered, which scheduler is watching for always. And once the scheduler gets the event that, okay, one pod is created, so it will then uh, actually schedule for one new activity to create the actual pod. Okay. And this, and scheduler also handles the selection of the node on which this pod particularly basically go to. So this pod will be assigned a particular node. Okay. So in context of, let me clear this. Yeah, so what happens is like this scheduler has also main thing, like it handles the selection of nodes which will best fit for the particular pod that we are going to create, because it's possible that pod can have a previous pod that is being restarted could have a previous persistent volume as well, which, and that particular volume could be present either on this node or it could be present on any another node, right? So basically scheduler also takes care of that matching logic, where this needs to be scheduled, or which one is the uh, less occupying node, and so load balancing also it's take care of. So means the better, whichever node fits the best for this particular node, that's basically that node id is basically assigned to this particular pod. And once that is basically assigned, then only once that is assigned, then only it create API server again creates an event, which for which this kubelet is always watching for. Okay, so this kubelet could be this kubelet is the one, it is present in all of the nodes. For each node, each worker node has the kubelet and the kube proxy, and this is the container runtime which will basically instantiate the container, right? So docker is in this case. So what's going to do is it will always listen that pod needs to be created. So, and if it will validate that is it meant for this particular node or not. So uh, basically API server takes care of that actually as well, where only the node which is associated with the particular pod where it is need to be created, only it sends to that particular node the event, and that kubelet will take care of the invoking the container runtime, and then actually starting the container. So that's how it works basically. Here let's talk more about the other components that we had. uh, Other one was controller manager, that we also taught, that deployment controller, replica controllers, and other controllers could also be present, something like endpoint controller and uh, other thing. Yeah, scheduler we also understood, kubelet and kube proxy. Okay. Now let's get to the more fun part, where we will dive more depth into okay, now let's understand the how basically each pod communicates with the other pod. That is also very important. So what happens is, let me grab the diagram tool. So let's suppose this is one of the node, and Okay, so let's understand this scenario where we have two nodes and each pod has its replica on the another node. So pod A also has replica on the another node, pod B has replica on the another node. And let's suppose that here node A wants to communicate to node B, which is it's possible that the pod B is down on the node A itself, so it's trying to communicate with the other instance, which could be present on the node B as well, right? And also it's possible that the communication can happen the other way as well. Let's suppose pod B wants to communicate with pod A, where in that case it's going to communicate with pod A internally. So how does this communication actually happen? We are aware that each node has its own private IP address, right? It's possible that it is something like 10.1.1. Something. It could be anything, 12 or something. That we don't care. So each of them has its address. So whenever a pod is created, each pod will have its own IP address. Okay. And what's going to happen is uh, each each of these pod each of these pod will have this particular address of, let's suppose, so here let's suppose yeah, let's define what happens is like each node has its own bridge. So let me write it down. Yeah, so this is a bridge and each of the each node can define a particular subnet, and where it is something always like let's suppose if the subnet IP is, let's suppose it is for 110.1.1.0/24. It means that first three octets, skipping the first three octets, then the last one comes. So here all the pods will be assigned from 10.1.1.1 to 10.1.254. So each pod under this particular node will come between this range. Then someone might ask, what about these two addresses, 10.1.1.0 and the 10.1.1.255? So these two are special IPs. This first one itself represents the subnet itself, so it doesn't get assigned to any other pod. And this one 255 one is reserved for the broadcasting. So if any message published to this one, then that packet is delivered to all the IP under this particular subnet, right? And also so what's going to happen is like each of these pod is connected through this bridge. Okay, let me write this is a bridge, and each of them are connected through a virtual Ethernet. So here same thing, for pod B. So what's going to happen is like these pod are going to connect with the virtual Ethernet. So let's suppose you assign this one as a 10.1.1.1 and this one with 10.1.1.2. then each of them will whatever they want, the message that they want to communicate, so they will each packet will have information of source and the destination IP. So they will travel, this message will travel through here to here, here to here, and then this will go to bridge. Similarly, this message from here to here will connect through the virtual ethernet, and from virtual ethernet goes to bridge. Since the bridge is same for both of them, the message can easily transmit through within the same node. So it's very easy because it follows this no network address translation here. I'm a bit rusty with the Excalibur, excuse me for that. Yeah. So it's going to follow the messages between them. It can easily communicate because it doesn't follow address translation, right? It is netless, you can say. So within the node the communication can happen very easily, that is fine. But what about this type of communication, the when the source is pod A from the node A and the destination is uh, so let's suppose this is one of the packet where the source is, and let's suppose the address over here is something like 10.2.11. Okay, and the here similar thing will happen, but instead of this one it's going to be 2. So let's suppose it's going to be 2.1, and again going to be 2.2. So these IP addresses, so source will handle this is going to be here source, and again the destination, so then one might ask, like, how does this communication actually happen? So what happens is, like, let's suppose if they are connected with a network, okay, these two nodes are assuming that they are part of the same local area network, so they will be connected with the physical layer. So a type 3 routing happens over here. So yeah, so communication between here and here happens. So what's going to happen is it's going to send this particular packet over the network. There is no, so this is sort of like a special handling where though no router are involved, because router is itself whatever the private IPs are there, those packets are get rejected by the router. So there are no router will be involved. And in this case easily this routing can happen in assuming this is our own current local setup, or maybe you can say on one particular location where you have two multiple nodes. But one might ask, like, why can't the particular these nodes can exist in several different remote location as well? Not remote, I mean in a more zone aware nodes, like zone aware cluster. So in that scenario what's going to happen is, like, Kubernetes provide a plugin as well, so where you can uh, where you can basically provide your own CNI plugin. Okay, CNI is nothing but container network interface. So this container network interface is like so many. There are like Calico and other like Cilium as well. There are so many other network interfaces which can be used. Calico is like the most simple one, so this could also be used. Now so this makes things easy because this communication happens over the network. So yeah, these tools handles it basically whenever the packet this leaves the network, it does the encryption and everything, and then whenever the packet gets delivered to a particular node, uh, it's going to be retranslated, and those encrypted, that gets decrypted, and this same packet will be delivered to uh, this port basically. So these are handled by Calico and Cilium, which I am not completely aware of. So yeah, you can explore more on this. So yeah, I think that was all that I had to share. Uh, Basically what I understood. So, and there is also one more tool like Flannel as well. Flannel, Weave as well. So these are some of the most famous ones which are used for the as a CNI plugin. So yeah, that is all. Thank you so much.